In this video we're going to talk about servos, specifically these very, very cheap servos you can get on Amazon for about anywhere between $5 and $2. These little blue ones I think you can get for like $2. So this one says Tower Pro Micro Servo 9G SG90. This says Tower Pro, this is not a Tower Pro. This is like a knockoff. They all just seem to get the Tower Pro sticker. It's a micro servo, so that's the form factor of this style. And I don't know what this one's called, but obviously the micro servo is smaller. So SG90, if you search for that, you'll find this. 9G means that this has 9 grams of force that it can apply at the output shaft here. This output shaft is called the spline, and you can see, this is very cool, you can see all the gears inside, and they're plastic gears. So these other ones, this is an MG995, high speed, digi high speed, and you can see the two splines here are plastic and metal, and they're different sizes. So MG generally means metal gears. So this has plastic gears, this has metal gears, and usually, you know, you get a little bit more life out of that. This little spline adapter piece is usually part of, you know, the kit when you buy them, and they come in a bunch of different styles and shapes. And generally, when you buy a servo, you will get a bag of different pieces to use. So you have like a cross one, you have a circle one, you get the straight one. Sometimes I have this crazy star one. The other servo came with a few different ones as well. And then you have you know, various mounting bits. So this was a more expensive servo, this one here, and this was the one that came with that other little mounty rubber things. That's kind of cool. But these cheapo Amazon ones, they will come with these grommets and these pieces that look like I don't know, part of a rivet. Some screws to screw them into stuff. And so first, you know, what can you do with a servo? Well, servos are for precise motor movement. So for example, something like this robot claw, you can move up and down. This is a servo. And then this servo is mounted down here, opens and closes the claw. This is another style servo you can get on Amazon from Liwan Soul. This one's like $17 or so at this point in time. And this one is a little bit more torque, I guess. And it's not really like that much better though. I'll be honest, was not really worth the money. So servos can range quite drastically in price. We're just going to focus on the cheap ones here and talk about, you know, what makes them cheap and you know, what is a servo, right? So what's inside of a servo? Well, if we bust this one open, you can see on the top you have gears. We've got the output shaft goes to this gear, which goes to this gear, jumps up, and this one goes down to this final bottom plate, and the motor is underneath here. So we pull these out, we have a shaft in the center, covered in oil, which is good for lubrication. And we take off the output shaft. Underneath here, this is broken. This is in fact broken. You can see the output shaft has a little piece right there in the center, and this piece is broken. So this is where the magic happens. This is where there's a potentiometer that determines, well, it doesn't determine, it tells you the position of the motor. And that's how a servo works. The potentiometer tells a microcontroller inside of here the position of the motor, so you can precisely recall positions. So that's the potentiometer down there. It has the words B5K. So it's probably a 5K potentiometer. And these are probably the output MOSFETs for the H-bridge circuit, you know, which allows the motor to turn left and right, is what an H-bridge does. And we have 3 wires coming off of here. So there's, you know, there's a microcontroller on this side, and the interface is just a 3-wire PWM circuit. So orange is the PWM signal, and red and brown for power, red being positive. So that's what a servo looks like on the inside and how one works. But let's plug some into this nifty servo tester and see for ourselves. So here I've got this fancier servo. This one was about 10 bucks. I don't think it has popped up on Amazon yet. It's a little bit more expensive. I've been trying to find a reasonably priced servo with my budget being, you know, I don't know, 10, 15 bucks. You could buy a servo, you could spend like $200 on it. That's crazy. I'm gonna break them. I know I'm gonna break them, I don't care. Okay, so when I turn this lever, I could see the servo moves and it goes to the precise position that this is dictating. So once again, great for robot stuff. You know, they have all these different adapter pieces you can get. This one has a bushing on this side, a brass bushing, and then the output spline over here. So you can get all these cool little adapter plates and stuff. So you can, you know, come up with all kinds of crazy ideas. It's fantastic. The bushing on there brings up another good point. See, inside of here, inside of this, the top of this servo, this is our 996R, where the output shaft is, there's a bushing in there. It's not a bearing. So fancier servos have bearings inside. This $10 servo, it does have a bearing inside. The Lee Wansel, it does have a bearing inside. What's the bearing good though? What's it going to do for you when, you know, the H-bridge burns out? It doesn't do much. So, you know, a brass bushing is fine. For example, this is the middle pin out of a different servo that I took apart. So I have two sets of gears over here. It's the exact same one that I took apart from another one, and that center pin just bent. So, I mean, you get what you pay for. For $5, I mean, I'm not complaining. Just keep in mind, when they start acting funny, you probably just got to replace them. You can open them up and it's a big mess, but, you know, whatever. Okay, so now we know what a servo is. We kind of know, you know, a little bit how they work. Let's really dig into how they work. I'm turning this knob, and this number is changing. When I go all the way this way, it says 800, and I go all the way the other way, it says 2200. What does that mean? And this servo tester has a few different modes. There's two buttons. There's select and pulse width. So if I do select, it goes to centering mode, which is 1500. What does that mean? We'll get into that. Okay, go into this mode, and it will just cycle the full range. That's pretty cool. And then again, and if I hold it, it shows me the mode it's in. So S2, S3, S1. S1 is custom. Okay. And then the second button, pulse width. If I hold it, it says 125. If I hold it again, it says 250. If I hold it again, it says 50, 50H. So 50 hertz is the signal, the PWM signal that this is outputting. That means 50 times a second, this is turning on and off. And then this number here, so 50 times a second turning on and off, and this number here says how much of that 1500 seconds, how much of that 50 times a second is the signal turned on. So to learn more about this, let's look at the oscilloscope. The oscilloscope shows you the signal coming out of the servo tester. Look at that. How cool is that? So if I go all the way this way, it goes all the way that way. If I go all the way this way, it goes all the way that way. Okay, so what is this? This is how much, 50 times a second, this is turning on and off. And how much time is this actually turned on out of that individual period of time? Does that make sense? I hope that makes sense. So if you see here it says 800, what does 800 actually equate to? That's 800 microseconds. See, that's what the US means, or 0.8 milliseconds. Okay, so if we go to 1,000, That's a little easier number. 1,000 is 1,000 microseconds, or 1 second. And so if I click this button up here, you can't see, I can turn this dial and measure the signal width. So this goes from microseconds to milliseconds. So it's 1.03 milliseconds. You know, I'm not getting it exactly on here. I could zoom in. I could zoom in and get a little closer. You know, it's really close. This is outputting a good signal. Okay, so that is our signal coming out of the servo tester. How cool is that? Okay, and then if we zoom way out, now we can see the individual periods of 50 hertz. So this is turning on and off 50 times a second. And if I change the pulse width, now it's 125 times a second. So now I see twice as many on here. If I press it again, 250. So now it's turning on and off 250 times a second. And if I press it again, we're back to 50 hertz. Okay, so now we can zoom back in. Okay, and then we see, go all the way. Zoom it in. And now we can see this is 2.2 milliseconds. So 2.2 milliseconds, or 2200 microseconds, the signal is turned on out of the 50 hertz duty cycle. So that is how a servo works, and that is what PWM is and how it applies to servos, as you can visually see. How cool is that? Come on, that's awesome. I love technology. So in the next video, we're going to talk about this servo or PWM LED controller and how to hook it up to a Raspberry Pi. This is the PCA 9685. It's a fantastic chip, and we're going to hook this up to a Raspberry Pi and drive these servos, you know, because that's what you do when you have a robot. You got to drive the servos from a Raspberry Pi. Stay tuned. Thanks for watching.